In the last module, we built a child component and walked through several techniques a parent component can use to communicate with that child. Now we'll look at communicating in the other direction. Welcome back to Angular Component Communication from Pluralsight. My name is Deborah Karata, and in this module, we examine how a child communicates with its parent. With any healthy parent and child relationship, it is not only important for the parent to communicate with a child, but also for a parent to listen for information from that child. Here once again is our component communication diagram. Our focus in this module is on the communication from a child component to its parent. In this module, we look at several techniques for communicating between a child component and its parent, then focus in on output properties. Let's get started. We've seen several ways for the parent to communicate with its child. The parent can pass a value to the child using the input decorator, or the parent can access the child properties and methods directly using a template reference variable or the viewChild decorator. But we found that there is no easy way for the parent component class to determine when a child property changes. In that case, we really need the child to notify the parent of the change so the parent can react appropriately. There are several reasons that a child component may need to communicate with its parent. The child may need to notify the parent of changes or other events. In our filter by example, the parent needs to know when the child's filter by value changes so it can filter the list. The child may have data that it wants to provide to the parent, such as the result of a calculation or a message for display. A component has several techniques it can use to communicate with its parent component. The most common technique is to use an output property defined with the output decorator. This allows the child component to emit events to the parent component, providing notifications. The child component can provide properties or methods and expect the parent component to access them. The parent component uses a template reference variable or the viewChild decorator to obtain a reference to the child component. Then once the parent has that reference, it can access the child's properties or call its methods. We walked through these techniques in the prior module. And of course, though not shown here, we can use a service as an intermediary to communicate between the parent and child. We'll look at services as a communication mechanism later in this course. Let's focus now on the output property technique. The key mechanism that a child component uses to communicate with its parent component is to emit events. The child can notify the parent of a change event or click event or any type of custom event. The child can pass data as part of that event. That data is often called the event payload. To send out these events, the child component defines an output property using the output decorator. The child component uses that property to emit an event and optionally sets the event payload value. A parent template can catch those events using event binding, access the event payload, and call a method to react to the event. In this example, by filtering the list. Does this sound a bit complex? It's really not. It just requires several steps. Let's try it out. Recall from the last module that we modified the product list component to display the list filter value. Let's delete that before we begin. So, how do we implement filtering when the filter criteria we need is in the child component? We set up the child component to emit an event every time the user changes the filter by input element, and pass the current list filter value to the parent as the event payload. We'll start by adding a property to the criteria component class that can emit an event. I'll call it value change. Since we want this property to emit events, its type is event emitter. I'll use the quick fix here to add the associated import statement for event emitter. Next, we define the type of data that will pass with that event and specify that type as the generic parameter. Since we want to pass the changed filter by value, we define the generic parameter as string. If we want the parent component to use event binding and catch this event, we need to mark it with the output decorator. Because even though we are not passing anything to it, the output decorator is a function. And I'll use the quick fix feature to add the needed import. It is customary to initialize the declare. Start to use it to emit events. So we set our property to a new event emitter, setting the generic parameter as a string. Next, we need to actually emit the event. Let's think about that for a moment. We want to notify the parent component every time the user changes the filter by input element. How does the child component's class know when the user changes the filter by input element on its template? Luckily for us, we covered 3 techniques earlier in this course when we looked at how a component communicates with its template. In the child component's template, we could use a modified version of two-way binding the long way. In the child component's class, we could use a getter and setter. Or we could use the view child decorator to get a reference to the ng model directive and monitor its value changes observable. Let's go with option 2 and use a setter because it's straightforward and keeps the logic in the component. Going back to the code, note that we can't use the ng-on-changes method in this case. The ng-on-changes method is only executed when one of the input properties are changed by the parent component. We want to watch for user changes to one of the child's local properties, so we need one of the techniques from the prior slide. Looking at the criteria template, we see that the filter by input element is bound to the list filter property. So it is that property that will convert to the getter and setter syntax using the pattern we examined earlier in this course. First, we delete the property declaration because we can't define the property with a declaration and a getter setter. Then we add the getter and setter. I'll paste the code following our pattern. We declare a private backing variable. Then we define a getter that returns the backing variable and a setter that takes in a value and sets the backing variable to that value. Each time the user modifies the filter by input element, the setter is called, so it is in the setter that we want to emit our notification event to the parent. To emit an event, we use our output property, this .valueChange, .emit, and pass along the changed value. That changed value then becomes our event payload, so our child component changes are complete. In the product list template, we catch the emitted event using event binding. We use parentheses around the output property name, which is value change in this example, to denote event binding. We then specify an expression or method to execute when the event is caught. We'll call a method named onValueChange and pass in $event, which holds the event payload. Looking back at the criteria component, the event payload is the changed list filter value. Since we bound the event to a method, we need to create that method in the product list component class. We named the method onValueChange and passed the event payload in as a parameter. In this example, that payload is a string. And this method doesn't return anything, so we define its return type as void. In this method, we simply call our performFilter method, passing in the value to use as the filter criteria. Checking it out in the browser, and the filtering works. Yay! Let's not touch it again. Going back to the code, let's review where we are with our parent and child components. Our parent is passing configuration and hit count information to the child, and the child is emitting user change events back to the parent. Each time the parent is notified of a change, it uses the changed value to refilter the list. Cool! Let's finish up this module with some guidelines and a summary. In this module, we focused on one key technique for communicating with a parent component. When a child component needs to communicate with its parent, emit an event using an output property. Use this technique anytime the child needs to notify the parent of an action and optionally pass along some data. In this module, we focused on child-to-parent communication, and we walked through how to use the output decorator to define an output property and use that property to send event notifications from the child to the parent. In these last two modules, we've examined techniques for communication between a parent component and its child component. Up next, services.